Okay, let's talk about why I hate the division symbol and how the order of operations, how you can teach order of operations better. All right. So generally, when people are teaching order of operations, the classic, you do the PEMDAS. P E M D A S. And basically, each of these corresponds to the order that you're supposed to perform, like you're supposed to evaluate math. Okay, so P is the parentheses around something like that. E is for like exponents, so x squared. M is for multiplying things, so like A times B. D is for dividing things, A divided by B. A is for adding, so plus. S is for subtracting, minus. Okay, some kids get the wrong impression though when they're dealing with PEMDAS. For example, if you have, maybe we should change the color. Okay, so if you have, for example, 12 divided by 3 times 4, if you're thinking along the PEMDAS route, okay, I always do parentheses first. Then there's no parentheses. Okay, what do I do next? Exponents. Okay, there's no exponents. Multiplication. There's some multiplication. It's time to do multiplication. Okay, that's what they would think. And it turns out if you do multiplication first here, then it's wrong. Let's try it. So 3 times 4 equals 12. Okay, those two equal 12. And then 12 divided by 12 equals 1. Okay, but that is wrong. That is the wrong answer there. Okay, so we're not going to do that. Turns out the right answer is if you do the 12 divided by 3 first, okay, which that will get you 4, and then you multiply that by 4, which gives you 16. Okay, so 16 is the right answer in this situation. So PEMDAS is kind of confusing in that way, and there's another way, that another kind of acronym that people talk about, and this is the one my wife uses when she teaches her 5th grade class, and it's called GEMS. So let's change the color again. Okay, you have GEMS. Same color, hate it. Go green. GEMS. G-E-M-S. And the way that this works is first G is grouping, which is just another way of talking about parentheses. You do the groups first, the things that are in the groups. It's getting by my head. Let's move it a bit. G is for the grouping, so parentheses. E is for exponents, like we talked about before, so exponents and square roots. M is just an M. Where's the division? Well, it turns out M actually includes multiplying and dividing. That's what they do. So M is multiplying and dividing, okay, which is keep consistency, AB and A divided by B, those two things. And S is for subtraction and addition. So that's how GEMS is different than PEMDAS. And what's cool about GEMS is you evaluate each group going left to right. You evaluate each section going left to right. So if we did GEMS when we're dealing with this problem, okay, and we had 12 divided by 3 times 4, if we're doing GEMS, we'd go groups, no. Exponents and square roots, no. Multiplication, division, let's look. Okay, there's multiplication and division. So what do we do when they're both in the same section? Oh, if they're in the same section, you go left to right. That's what you do. So you just, 3 divided by 12, 4 times 4 gives you 16. Right answer. Okay, so GEMS, you're more likely to get the kids to get to the right answer. But there are still some confusing things when it comes to this order of operations, because I thought, growing up, I did not do so good in math, and then I'm getting a little bit better now. But one thing that I was confused about all the time is, okay, if you have this order of operations, it seems like it's always going to be the case, even when you're doing algebra, right? You should always go left to right. And the way my mind works, I think like, oh, but some of the things I was doing in algebra were breaking this order of operations, and so that should give me the wrong answer. And yeah, in a lot of cases it does, but let's think about something a little different. Okay. The problem, turns out, is mostly because of this division sign, but let me talk about some things in algebra that break PEMDAS first. Okay, so let's say in algebra you have A times B times C divided by D. Okay. So in algebra, well, normally, like we talked about, you go left to right. That's what Jem says. That's what we're supposed to do. But if we have to go left to right, then it seems like this D always has to come after this C, always. But that's not how it works in algebra. So how it works in algebra, like this expression is equivalent to this: A times B times C divided by D. Okay, and in algebra 2, and algebra as well, this also is equivalent to this. So D divided by 1 times by A, B, C. A sad B. But that's also equivalent to if we did A divided by D times B, C. Which you can put this D under any of them. So you can put the D under this one. But that doesn't seem to make any sense, because you have to go 1, 2, 3, and then go over to this. You have to keep things going like left to right. So let me finish this one to be consistent. See? Okay. You have to go left to right. So this would be like B divided by D times A times C, wouldn't it? And yeah, maybe, but the thing that I hate the most is this stupid little division symbol. It's ambiguous, okay? You don't know what's going on. So when we had that division symbol before, right, with our previous problem, okay, where we had the 12 divided by 3 times 4, the problem is this stupid division guy. Okay, that's the bigger problem. And it's a problem because what does it mean? Does this expression mean 12 divided by 3 times by 4? Is that what we're supposed to take that expression to mean? Or does this expression equal 12 divided by 3 times 4? I'll just consistency, have a dot there. So is the scope covering this whole thing? Is that where the scope is? Or is the scope just here, covering those two things? So we're left with like that kind of strange ambiguity going on, where we don't know exactly what we're dividing. Okay. But is this actually a problem? Let's see. Yeah, you see how this could cause problems. If we multiply the 3 times the 4 first, we're having that same issue that we had before, where that equals 1. But if we're doing the 12 divided by the 3 first, then that gives us 4 times 4, which gives us the correct answer, 16. So this guy causes some ambiguity between both of these. So I think that instead of writing any kind of fraction, like any kind of division problem ever with this guy, instead you should always write it like it's a fraction. So then you can clarify. Do you mean this? Or do you mean this? And if instead you wrote it as a fraction right off the bat, then we would know what you mean when you're writing that division. Okay, it just clears up that ambiguity. So if instead you write things as fraction, then you can kind of know what's going on. And the reason that this becomes wrong is these two expressions are not equivalent, not even algebraically. And the reason is let's write this as algebra. Let's pretend this is an A. Let's pretend this is a B. Let's pretend this is a C. Okay? So in the one situation, we have A divided, the correct situation is A divided by B times C. Okay. That is the same thing as saying A times C divided by B. Those two things are equivalent, okay? So you have that in one situation, but then in the other situation, for this one, okay, so this is this. For another one, you have the alternative, which is A divided by B times C. These two expressions are not equivalent, because what is happening with this C? That's what's going on. That's what's weird about when you're talking about these equivalent expressions. Let's look at the C, okay? This C in this expression is just a C over 1. So if we write this C as a fraction, it equals C over 1. And this C, if we write this as a fraction, is equal to 1 over the C. That's totally different. It's the same thing like saying 1/2 is not the same thing as 2. Okay, so that we can clearly see what is happening to this number here when we write it out like this. This number is changing. Okay, maybe I'm the only person in the world that has ever had issues with the regular division symbol and what that means when it comes to algebra. But I don't know, that's just the issue that I've been having with it. So there is that ambiguity when it comes to this, and these things mean different. These expressions aren't equivalent, and we can see that very clearly algebraically. You can't just yank the C out from the bottom. At least maybe my years of intuition of doing math without actually understanding tells me you can't do that. But you know, when you have this idea that you have to go strictly one way to another, then I just start to worry about my order of operations going on over here. And you don't have to worry about them the same way. You don't have to do order of operations left to right when it comes to algebra. You don't. But what you do have to do is keep your fractions consistent. That is the one problem. And I feel like no one talks about that much. And it really confused me. And I reached out to my friend and he told me he hates the division sign. And I was like, you know what? That's my problem. So sorry if this is a little rambly. I just like to explain things to understand. And I wish you all a good day.